People always think we're attacking NASA, and we're actually NASA enthusiasts when it comes right down to it, right? We're space enthusiasts. We want accountability. We want disclosure. We want to see what's actually there, and we will accept the limitations. We'll support the limitations on what's capable of doing. We don't need to keep researching in and find out, oh, all we're looking at is CGI. If you can't do it, say so.
Ever since I started discussing the moon landing, and kind of the issue of the moon landings was kind of what got me very seriously into the alternative field on all kinds of subjects. As Marcus said in his program with John Ronson, he said, you know, when you think, well, this is wrong, what else is? So once I realised there was something wrong with the moon landings, I started thinking there's things wrong with other things as well. And that got me into the whole alternative field. The funny thing is, when I started to write openly about questioning the moon landings, it was on the Owlis forum, the old Owlis forum, which was a really good platform, actually, in the old days, in the sort of late 90s. There was a couple of people like John Witts, he was all right, I got on okay with him. But when I then moved on to the Dark Conspiracy forum, I encountered people who, firstly, be very rude to me, literally abusive. Then it got worse and worse and worse from abuse to acts of, statements of defamation against my character and threats against my family, things like that. I called the police at one point because they were saying they were going to call my employers and tell them that my mother had. They said, quote, my mother accused me of child abuse. That's a very serious matter.
What were the things that you were saying that generated this type of response?
Exactly the kind of things that we talk about on our programs. This is why Steve Mumbling doesn't really bother me very much. Because I've grown quite a thick skin over the years, because he's quite a softie compared to some of the people I've had to deal with in the last couple of decades.
That might explain why my book got removed from Amazon. All of Trevor's books have been removed.
Oh, no, I bet it's misinformation, they call it these days.
Hate speech.
Oh, hate speech, that's another one, yeah. Hate speech or spreading misinformation. See, it's getting worse. It's got worse very suddenly, because there was a time when at least we were allowed to say what we wanted to say and to ask the questions we wanted to question about the subject we discussed. And then suddenly, it's literally only the last few years, there's now only one official story on everything. And anything that counts as it at all is a conspiracy theory. I mean, that's when they've been nice to us, they call it a conspiracy theory. Other times it's hate speech. And it's misinformation. Posing misinformation has now become a case of not just saying you're wrong, people telling us we're wrong. I don't mind people telling me I'm wrong, because I can argue with them as long as they're polite. But now it's a case of passing laws, getting them to sue you and things like that. It's saying, well, you're causing offence, and that itself is now a crime. I get the feeling that there's going to be some massive showdown. The two sides are kind of, the gulf between the official people who believe the official story and people like us is widening and deepening. There's less and less dialogue. And that's why the programs we do, I think, are so important. Because we have to keep talking about this. We can't let ourselves be intimidated into silence.
Individuals never had this kind of a platform before to speak. And some of the most twisted people on the world are out there, and they're getting attention that they shouldn't be getting. Right?
When Randy and Marcus went on, it was a good opportunity to throw a little bit back at the other side because of what Steve Mumblings did. It really shows what kind of people they really are. And I wasn't going to just sit back and let that go, but when I saw that opportunity, it was so well done that I thought, great, I can really make something out of this, just 30 minutes, just to push back a little bit without getting too out of hand. And that was a perfect opportunity that Randy and Marcus gave.
It was a perfect time, actually. When Mumbling was on our show, I think he did, we've said this many times before, he showed the weakness of his argument. He showed how belligerent the other side is getting because they know their argument is under threat. They have an ideological commitment to a particular worldview. That is that NASA sent 12 astronauts to the moon in the 60s and in the early 70s and brought them back again, plus the Apollo 8. They have that ideological commitment. Yeah. It's not like, well, I think it, and when that's threatened, especially if I don't think in mind if we were just talking nonsense about flat Earth and things like that. We're not. It's a proper scientific case we're putting forward, and it has value, and that upsets them because they don't want it to.
Yeah, and they can't argue against it because they're usually less well informed about NASA and the Saturn V rocket in the Apollo missions than we are, because we've spent, well, in my case, nearly 30 years looking into it.
And they descend into abuse. They call people names, like Mumbling did. He did stuff to me, to Scott, and people like that, and calls us all names, doesn't he? You get the same thing everywhere. I mean, here in my city where I live, in Oxford, people who are now opposing things like the 15-minute rule, that's a long story, I won't go into details now, but basically it's a pilot scheme for an urban planning and traffic control system. We're being called far-right extremists.
That's right, that's a normal insult, they're far-right extremists.
You know, the funny thing is, they come out and attack us. What I present is NASA's official documents, NASA's official photographs and videos. That's what we're presenting here. So for them to attack what we present, they're actually attacking NASA because of their inconsistencies, right?
Yeah.
And then when they update those and change the context of which that document is to be presented again, now you have two sides, and these guys are arguing against NASA's own documents. I don't offer an opinion, I'm just pointing it out. I'm saying, here's NASA documents, here's NASA photographs. This is what's in the photographs. I didn't take the photograph, I didn't modify the photograph, I didn't do anything. I'm showing it to you right there, it's right in front of your face. The flag is wet. Okay? I didn't wet it down, I didn't modify it. I didn't go to anybody at NASA and say, let's play a joke on the world or anything like that. Okay? That's their photographs. Just because they couldn't see it there, and that's with every other thing that you show. Buzz Aldrin in the door frame. I didn't make that model and not put a console on the inside of it. NASA did. Buzz Aldrin stood up against the door frame, either intentionally or not intentionally, because he needed the space anyway. It's a small space in there. Of course, he's going to use everything that's there. All they needed was that frame, Mylar on it, and then ladder down to pull off the fakery, right? And when you point that out to them, I did not create that situation.
No, but they get very upset because either they haven't seen it themselves or they have seen it and can't explain it. They say the only way to remove that as an objection is to attack you, which is what seems to be happening.
Right. They need to be attacking NASA when they claimed that there's no way they could fake it. And like I said, they couldn't fake it. But they filmed it anyway.
Yeah.
Okay? And we're pointing out where the errors are in that fraudulent video that they produced, in the photos they produced, in the documents they produced. That's all we're doing, and yet we're attacked.
It's the old saying from the RAF in World War II. Attacks are heaviest when you're over the target.
Precisely. This is something we should rejoice about because it means we've made progress. They used to ignore us, you know. They cancelled James Oberg's book in NASA. James Oberg was going to write a book debunking us and cancelled it. They commissioned him and then they cancelled it. I think he published it independently anyway. But now everyone is now responding to what we're saying, and they're doing so in essentially an act of desperation. They say, well, what would you know? You don't know enough because of this and that and the other. You get this thing wrong about these details and this detail, and it's clear that you have no education and things like that. Well, that's not relevant. It would be a breath of fresh air if they just said, look, I think you're wrong about this, Ben, Marcus, Scott, Robert, and this is why, and they just left it there and allowed us to respond.
It's quite extraordinary how much garbage you have to put up with. Basically, I ignore it because there's no point in even giving oxygen publicity to it.
Because you can't find anything on film, any documentations on film. I've been downloading stuff. There's a whole bunch of stuff just on Mylar. Right here, 3 documents on Mylar, and the physical properties of Mylar, because it's exactly the same as film. So what we were looking at in the chamber, take a look at aluminum. This is the temperature at which it starts to vaporize at 1 atmosphere. See the difference in temperature? How the effect is? At -4, it takes very little temperature to vaporize it, right? Come down to mercury, 10 to the -4, it just vaporizes. Gone. Well, guess what? When you take these numbers, you take mercury is at 682 degrees, considering each material reacts a little differently. Mylar is 392 degrees. Like I said, each material reacts differently. Like this one's drops by half the temperature, right? This one drops by 2/3, right? This one drops by 70%. Mylar, like, it's not listed in here, right? They're not doing it, and the film's not listed. But these different temperatures, as you lower the vacuum and the effect it has on the temperature that they vaporize at, right? And then the Mylar is going to be in there. It's going to start to vaporize when you pull the torr value down, right? They all don't come down by the same percentage. Each has its own properties on which it off-gases at what temperature, right? But I was looking up the Mylar to see where it vaporizes at in there under normal air pressure, right? It's 392 degrees. Then I came across this little piece here. These are the different, for a differential gauge. And the only thing you need to do is read the bottom line.
Reading the maximum pressure range will destroy the sensor.
Okay, now, that is a mechanical device. It's a measurement of force. And I've been trying to explain, to make it simple, on what people need to understand about the torr scale. So here's what I've come up with. Take a container and put a lid on it and close it. You put a pressure gauge on it, it says 0 because you're in an atmosphere.
Yeah.
And you put it in there. Both are the same. But that is 760 torr that's in there. You can't read it because there's no differential between the outside atmosphere and what's in the thing. To get to 0 torr, so let's just remove the outside atmosphere. And we're going to take that container, it now has 14.7 psi in it. We're going to make the chamber larger and larger and larger so that the air inside, the molecules inside, are not pushing against the container that it's in, so that they're fully relaxed.
Right.
Those air molecules want to separate. They don't want to be tight together. They want to be a certain length apart. And when they become that certain length apart, you are now at 0 torr. You still have 100% air in there with 0 pressure. When you come down from 760 torr, you're down to 0. If you're going to go into the torr to the minus, you can either make the container larger or you can take away the air molecules inside. And that's what Bill is doing with his vacuum chamber. He's removing the air molecules inside. Now, they don't want to be in that space. The pressure is the opposite direction. It's going to want to bring the walls in. It wants to be back at 0. Its natural state is to be in 0 torr, 0 pressure. The molecules want to be a certain length apart, away from each other. If you take an air shock and you push it down, it wants to push back up. And if you pull it apart, it wants to come back in. It wants to equalize itself. It wants to be in that neutral state. This is where they don't understand. A vacuum is nothing, right? But the air molecules in there are acting on each other to pull themselves in. This is where the pressure is coming from. So you take that container and you start removing the material. It wants to make the container smaller until it's in a neutral space. Like, it wants to be neutral. It doesn't want to have any pressure. So you take it from 760 torr down to 0. 10 to the third is 1,000 torr. 19.3 pounds or something like that. So torr value of 10 to the minus 3 is creating the same pressure as 10 to the third and 10 to the minus 3 each have the same force. And that differential gauge is measuring that force. When you go to 10 to the minus 4, now it's 193 foot-pounds per square inch. And it has nothing to do with percentage. And people go, oh, it's a percentage, it's this and that. It's not. Because at 0 torr, we still had 100% of the oxygen in there, or atmosphere in there. It's just in a relaxed state. When both sides are at equal, both can be under atmospheric pressure on both sides. There's no differential in pressure between both sides, so it reads 0. So when you're coming down from 0, you see different people and they go down, well, 0 pressure, 0 atmosphere, so it's a perfect vacuum. It's not. Otherwise, you couldn't go down in the torr scale. You're removing more air molecules out of the chamber to create that effect. But it's also logarithmic. So when you go to 10 to the minus 5, how many 1,000 pounds pressure per square inch are you creating? Because it's literally wanting to bring the container smaller down until it is neutral. When you see a diagram, if you just look up differential vacuum gauges, they actually have a diagram of the actual sensor. It is a mechanical device. It's just little tubes and whatever with two plates on it with different tubes of liquids in them, right, that measure the pressure. Just like a standard mercury switch, a spring, anything like that. But it's a mechanical device. It's measuring the physical force. And the force is not coming from the vacuum. It's coming from the molecules.
That's different, isn't it? Very different.
And that's why they say a vacuum doesn't suck. Well, the molecules are trying to pull that container back down to its neutral state. And that's the only way I can explain how that vacuum is and why the torr scale goes back. Like you see these other guys, they go, 760 torr to 0. 0 is 0, right? And they can't go down to the minuses. I even saw a guy say, well, it comes down, it goes down to here and down to minus 17 and then 0, which is 0 air pressure. Well, you're being fooled about reading a gauge because you have to account for the atmospheric pressure you are currently in. Like I said, you just grab some atmosphere and put it in a container and close it. You have 14.7 psi in there, but you can't read it because you're also standing at 14.7 psi. So even a differential gauge doesn't read it.
Fascinating stuff you've got here. Basic principles of vacuum technology. Where did you find this?
Oh, I've got a whole bunch more than that. I got tons more. I just picked out ones that would be applied to just for this. And then I went after Mylar because you can't go after film. It's the same damn stuff, though. That's the problem. NASA forgot about that, didn't they?
Yeah, they did. NASA forgot about a lot of things.
Like they forgot that all of the companies out there that produce Mylar for everything have all the specifications on them, including the vapor temperatures.
That's quite an important point because that is the point at which material...
Where it starts to break down.
Yeah, that's what I mean. It breaks down.
Yeah, but you're seeing it -1. It's starting at -1. There are things happening at -1. If you leave it long enough, it will happen, right? The thing is when you get to -11, how fast will it happen?
Wow, yeah.
When you see a thing saying a differential gauge exceeding the maximum vacuum will destroy the sensor, I mean, that is physical force. So how strong is that? We can build gauges that will read 50 to 100,000 psi water pressure. What, the diesel engines are now 35 and 40,000 pounds injector pressure, right? Well, how come they can't build a gauge to read the vacuum? If you can build a gauge strong enough to read 50,000 positive psi, how strong is that 10 to the -7 or 8 vacuum? It exceeds the capability to make the gauge. If I can build 50,000 psi to read water pressure, how much pressure is 10 to the -7? Because they can only do 6. It's a logarithmic scale. You can work it out in math. It's thousands of pounds per square inch. If it's over 200,000 pounds per square inch, that's what the problem is, and they can't build a gauge that strong.
Oh dear, and that's only halfway to the moon.
You're only at 130 miles. You can't even build a gauge to measure it.
So how did they land humans on the lunar surface?
Those freaking zippers were just the most amazing space suits I've ever seen. Those zippers, you imagine how ridiculous that is. You imagine how fast they trashed the Artemis one with the active rings around the waist. Take a look at Bill's video. Look at the very small diameter of space and how thick that material is and how thick the bolts are. Like that thing's built like a fire hydrant, right?
It is. It's built with inches thick stainless steel.
Across a very small diameter.
Yeah, very small diameter because the pressure is so great.
Anybody can tell you that there's only 14.7 psi on the outside of it. So where's the other force coming from? And that's why I described that force the way I did. Because people don't understand where the negative force is coming from, and it's a negative force. So you can put any calculator in and go 10 to the third is 1,000, 10 to the fourth is 10,000, torr. So 10 to the minus 4, like, it's 10,000 on the reverse. And it's the molecules that are creating the energy. Now we're back into physics.
That's why it's useful to have Bill there. Because
you can have 0 torr and still have 100% of the atmosphere there. Because right now we're living in an atmosphere with pressure, and that's 760 torr. But to bring it to 0 torr, you still have 100% of the atmosphere is in there. And it's when you start to remove it that the negative scale starts. Still a lot of atmosphere there. That's why they can use the machines to suck it out. Because when you get down to 0 torr, that's its natural state as a gas. Relax, it's not putting pressure anywhere. And then, of course, that's with everything.
have you seen those films of rail cars collapsing? And that wasn't at a very high level of vacuum. It's just removing some of what was inside.
When you get to somebody like Mythbusters, they're using a really good vacuum cleaner, because I looked up how much they can pull. So they can go from 760 torr down to 600 torr. So they're dropping the air pressure by a couple pounds. People simply don't understand that we're living in that. We already have that 760 torr all the time, right? Around us. Let's say that they bring it down by just 1 psi from normal atmospheric pressure. They're going to pick a vehicle up. It weighs 2 tons. So if they cover 4,000 square inches, they're going to pick 2 tons up. With 1 pound per square inch, 4,000 square inches is going to pick up 4,000 pounds. And that's how they do it. That's why it's capable of picking that up. I mean, they probably would have gone more than that. A spacesuit is 5,200 square inches, 2 square yards. One of the documents was 1.8 square meters, not included the gloves, boots, or helmet, which is basically 2 square yards. So you've got 5,200 square inches of material there. For each pound per square inch difference, you're putting 5,200 pounds against that is trying to pull a zipper apart.
It's not going to have much trouble in doing that, is it? It's going to come fly apart.
Never mind the air pressure trying to push out through all the cracks and stitches and everything else that aren't going to happen, because Bill can tell you about how long it took him. They had to bake that and clean it. I don't know how many times. They had to change the head up on it to a smaller container, because the larger one they couldn't get it to seal. They couldn't get it down past 10 to the minus 1. Whoever's working with it, they ordered new seals for it, everything else, and then they found the smaller container, cleaned it up, and put it in there. That's the kind of stuff that you're working with. You see how fast Robert's machine went to 0 functionality. And when I talked to Bill, he said, oh yeah, anytime you're finished with it, it's all sticky inside. Whatever you're working with in there is off-gassing all over the place, right? Everything's just sticky.
Now, do NASA mention any of this in any of their documents about vacuum?
No. They do not discuss the mechanical difficulties of preparing and cleaning the machines to even get them to start to work to bring the level down. And that is not in the documents.
So they haven't done the tests, not properly.
Oh, they've done the tests. I have the one on the test from 1965 on the film, and they brought it down to 10 to the minus 4. Doesn't say for how long or anything else. Their equipment could not be calibrated properly because Bill says that it's quite a bit to calibrate this equipment again every time you use it, right?
You see, they can say that they took it down to torr 10 to the minus 4, but it would appear that they didn't, or they didn't do it properly because they haven't reported it.
Or, like anything else, they just fudge the numbers and say it worked.
Yeah, there you go. I think you've got the answer there.
And they've done that with so many things. LeBlanc fell over, nearly died.
Yeah, he did. Yeah.
Just went ahead and certified the suits anyway.
They had to. Yes, the deadline. They had to get it done.
Yeah, but he was only down to 20 torr. They didn't even get that down to 10 to the minus 1. He was at 20 torr.
And he keeled over.
And you see how fast that they repressurized that tank he was in? You couldn't possibly open the door, and the pressure is back to, like, it has to be equal. Even 1 pound, the guy wouldn't be able to open the door even at 1 pound difference. Look at the square surface area of the door. 1 pound differential, he wouldn't open the door. It was almost back to equal within seconds for the technician to come in and see it. Like, that's just reduced air pressure. It wasn't down anywhere near what a vacuum does, right?
If it has that effect at that level, which is relatively low level, beyond that, we're talking serious consequences.
Yeah, they claim they got them to about 70,000 feet.
That's not very far at all. I mean, you could see it up there, certainly nowhere near space. So if they did those tests and they understood what they were looking at, what they were doing, NASA would have had a real problem saying we could go any further. A real problem, because they'd be risking the lives of anybody they put at that height.
I saw another test where they claimed that they certified the suits at 200,000 feet. And then I looked at how the test was done, and they're saying, well, they were 15 feet underwater, so that's equal to it.
No, it's not.
No, it's not.
It's not the same thing at all. Underwater is not a vacuum. It's the reverse of a vacuum.
That's right, because now you're back to that zero. You take a container and close the lid on it, and it's equal on both sides. You put air pressure inside the suit to match the outside pressure of the water. So the suit itself has zero pressure. There's no force happening.
Not a good test at all.
It's absolutely ridiculous how they try to pull stuff over and continue to do so. And even today, they're still using the water tanks. But they're not using the water tanks to test any equipment. They're using the water tanks not just for practice simulation running around the ISS. Don't forget they got that 65,000 square foot tank with an ISS in it. They don't need that big to do practice in. Sorry, they do it if they're going to fake a full simulation of a spacewalk. They need to get rid of the water tanks, all of their crappy simulators, and all of their movie studios and start practicing space travel. And then we'll see how far they can actually go.
They're not going to do it because they know that if they did it for real, if they had a real vacuum chamber and put people in it, and we saw the result, the first question most people would ask is, well, how did you do it for Apollo? And that's where Apollo falls apart. Don't have the testing available to demonstrate that they did it.
The difference between an unmanned craft and manned craft has to be pressurized. A whole lot more of consumables just to have them on board, but it has to be pressurized, temperature controlled, moisture controlled, everything else controlled in there. Now you got to build that craft a hell of a lot thicker just by looking at that vacuum chamber, what it needs to be. And they want to go farther than that. So it has to be even thicker than that. That's just for structural strength. Now we got to put some radiation protection in there as well.
Forget it. Not going to happen. They haven't got any yet.
And they need to come up with a lightweight material that protects as well as lead does. And those nano ones that are going around there is just like a little microscopic Faraday cage that they're trying to put up. I forget who was doing the talk on it. He said like you need a nuclear power station to produce enough energy to put the field lines up to protect you from the radiation. Just the same as the Van Allen belts, right? You're not doing with a watch battery. It's like everything seems to work when you go to space. It doesn't work. They do the test, it still doesn't work, and then they still claim that they used it and went there. That's where the huge problem is, and it's in their documents, it's in their photographs, it's in their videos, it's in everything. If you can't do a live video feed from Artemis in 2022, you are very sadly trying to carry on a fraud. They shouldn't have even done it. It should have been live video feed. They should have had 100 cameras on board that thing. Not animation. It's so sad.
It is sad, actually, because NASA have now got caught in this trap of having said they've done something when it's blindingly obvious that they haven't.
They're part of a government mainstay resource that's being funded money through, but it's all part of the tourism business. Those museums are making money for them. So it's just part of that up front. That's part of the promotions, like putting big posters up. Come and see our museums.
Because you've heard the story, now come and see the real. It's interesting, there's a connection which I hadn't really made properly before between the Apollo 1 fire, which is January 1967, and the death of Sergei Korolev, who was the driving force behind the Soviet space program. And he died quite unexpectedly, aged, I think he was about sort of mid-50s. He died in January 66, or early 1966. So there were two events were quite close together. And that's when it all started to go wrong for Apollo and for the Soviet Union. Following the death of Sergei Korolev, nobody was trained to take over from him. There was no natural successor. Mishin was the person who did take over. He was the head of one of the design bureaus. But he wasn't really at the same level as Sergei Korolev, who had the ear of the president, Brezhnev, and Khrushchev. He could get things done, and he could do things. When he was asked to do things for the certain anniversaries, he would do it, because he had the confidence of the people who worked with him and under him. People following him, they didn't have that same stature. So his death and the death of the American space program, or the lunar program, in the Apollo 1 fire, were fairly close together. And I think that those two events not necessarily have much to tell us, but I think we should look at the fact that two major figures, two major events, took place very close together, or relatively close together, and neither really achieved very much after that. The N-1 rocket, which was the Soviet Union's version of the Saturn V rocket, was a very similar design to Elon Musk's Starship. It had multiple engines. The N-1 rocket never launched. Well, it launched 4 times, but on each occasion, within a relatively short period of time, it exploded, because getting 30-odd engines to work simultaneously is very difficult. Whether Musk will do it better, I don't know, but they're having a lot of testing. But they're still not as powerful as the legendary F1 engines on the Saturn V.
Oh, they're fully upgradable now. The F-25 engines that they've got for the SLS, oh, they're fully upgradable. They boosted them from 200,000 to 500,000 because Musk now is claiming 500,000. I read the article. It says we designed them to be upgradable, so we just upgraded them to 500,000 pounds.
It's still a third of what was produced by the F1 engine.
Yeah, so now they claim 2 million between the 4 engines on there and the solid rocket boosters make it up to 7.8 million. That's ridiculous, because they don't do that either.